All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.3 in Pre-Calc. This is the second video in this section. So we're going to talk about trig identities. So we're going to spend more time learning these later, but these rules are a list of things you need to memorize, along with the unit circle. So it's going to be worth making note cards just to show you what I mean by a note card. You'd put one of these things on the front. So let's just get a pen real quick. Right, so I would put like sine on the front, right? Sine of theta on the front, and I'd put 1 over cosecant of theta on the back. Now there are other, as you'll walk through, there will be times that there are two formulae that could both be the back of the card. So for instance, you see a tangent equals some stuff here, and you also see a tangent equals some stuff here. So I guess you could put on the front side of the card like tangent quotient rule, quotient identity, and tangent reciprocal identity or something if you wanted. Or you could just recognize that when you see the tangent card, you would say, oh, it could be either this or this, and then you could check. I am a big proponent of physical note cards over something like Quizlet, because I do think you actually learn better by writing stuff, but you do you. So, all right, so there are these reciprocal identities, right? And we've already seen that the cosecant is the reciprocal of the sine, and the secant is the reciprocal of cosine, and the tangent is the reciprocal of cotangent, and so on. We also know that tangent is the y over the x on the unit circle, which is the sine over the cosine, and that cotangent is the flipped version of that, so that's cosine over sine. The Pythagorean identities, honestly, if you memorize this one, you can logic through the other two, and we're going to see these again when we get to chapter 5. So we're just doing a quick intro to them here. But this one makes sense because if you think about it, this is the y on the unit circle, quantity squared, plus the x on the unit circle, quantity squared, equals the hypotenuse of the unit circle, quantity squared, right? Because you know this side is cosine theta, and this side is sine of theta, and this is 1. So sine squared plus cosine squared should give you 1 squared, which checks out. So we're going to walk through it. You don't have to have them memorized like instantly. I don't think that's necessarily going to happen, but I would suggest that you make note cards. These are going to come up again pretty heavily in chapter 5. Along with some others, we're going to learn some others. And these are sort of the bulk of the first set you want to learn. I would start learning them now. All right, so we're going to use the trig identities to transform the left-hand side into the right-hand side. So basically, we're looking for something we can do to the left-hand side to make it look like the right-hand side, right? Well, in general, short rule here, if you have stuff that's not sine and cosine, it's a good idea to try and change it to sine and cosine. So I'm going to take this secant, right? I'm going to take this secant, and I'm going to change that to a 1 over cosine, because I know that that's what secant is, right? So I'm going to take this cosine right here and leave that as a cosine theta. I'm going to change the secant into a 1 over cosine because I know they're the reciprocal, and I'm trying to show that this equals 1. Well, the cosines cancel, and I get 1 equals 1. Ta-da! We're going to go ahead and try the same thing. You can try it without me if you want. You're going to change, so again, you're leaving this side alone, right? Cosine of alpha is going to stay the same, but you're going to change these guys. Again, my hint is if you have something that is not a sine or a cosine, try changing that first. So I'm going to leave the sine, sorry, my bad, that's not sine theta equals cosine, or alpha rather, of alpha. And I'm going to take this guy, and I noticed that, so there's two options for this, right? For this, I could use 1 over tangent theta, or tangent alpha rather, or I could use cosine alpha over sine alpha. And I could use either of them, but this one seems more beneficial in this situation because notice that the answer I'm trying to get also involves a cosine. I've already got a sine here, so I'm going to replace this guy, right, with a cosine over sine, and the sines cancel, and I get cosine of alpha equals cosine of alpha. And that's it. I'm done. Congratulations. All right. This was going to get a little bit harder. Again, I'm leaving the cosine squared alone. I'm going to suggest that you FOIL these because there is no rule that relates sine and cosine without squares right now. So if I FOIL, I get first, which is 1 squared. Outer is going to be a minus sign, and inner is going to be a plus sign, which totally makes sense because this thing's a difference of squares. And then I'm going to get minus sine squared. This thing sums to 0 because this thing is a difference of squares. So if you just saw that, you could be like, cool, I'm awesome at this. That's definitely a 1 minus sine squared. So I get 1 minus sine squared theta is supposed to equal cosine squared theta. And again, this thing's like a locked box. I'm not allowed to change this side, right? And then I think about that trig identity that said that sine squared of theta plus cosine squared of theta was 1. And I say, hey, what if I solve for sine? What if I said that sine squared theta was a 1 minus cosine squared of theta, right? So this is a trig ID. And I can say, hey, cool, wait a second, I could replace this sine squared theta, right? So this sine squared theta, eventually the highlighter will show up. There we go. I can use this formula to replace this thing, right? So I'm going to get that this is a 1 minus, and then in parentheses, instead of a sine squared, I'm going to write 1 minus cosine squared theta equals cosine squared theta, right? This is my locked box. And then when I distribute the negative, I get 1 minus 1 plus a cosine squared theta equals a cosine squared theta. So I get cosine squared theta equals cosine squared theta. All right, and then I'm done because I showed that the left-hand side was the same as the right-hand side. So you're going to go ahead and try this one. It's a little bit tricky. So the big hint is that, so as a hint, right, if you see squareds, it's probably the Pythagorean identities, right? It's probably the Pythagorean identities, right? And hint number 2, so hint number 1, it's squared. Hint number 2, the right-hand side is sine stuff only, right? So what I probably want to do is I probably want to replace the cosine, right? I got to replace the cosine stuff. So then I look and say, okay, cool. Well, what trig identity relates a sine squared to a cosine squared? And I know that I have a trig identity that says sine squared theta plus cosine squared theta is 1. Well, I want to replace the cosine, so I get cosine squared theta equals 1 minus sine squared theta. I can now take that stuff, we'll get the highlighter, right? I can take this stuff, and I can replace this stuff. So we get that this is a, I'm a little bit tight on space, I'll bring this down here. We get that this is a sine squared theta minus, in parentheses, 1 minus sine squared theta, right? And I'm just going to say equals, and I'm going to bring this stuff down later because I'm kind of out of space. When I distribute the negative, I'm going to get sine squared theta minus 1 plus a sine squared theta, which means I get, sorry, we'll erase that, which means I get a 2 sine squared theta minus 1. And if I bring this side down now, because I kind of ran out of room, equals a 2 sine squared theta minus 1. Yay, we're right. All right. Cool, that's it for that video.